The map X to AXA squared of a group G into itself is a homomorphism if and only if G is abelian, G is equal to the singleton, A is equal to E, A squared equals A, or A cubed equals E. Interesting. Okay, so the if and the if and only if case condition is the important thing here. Yeah, it's been a long time since I've worked with trying to verify, for example, that something is a homomorphism. I mean, if G is equal to only the identity, this certainly works, right? Because then E just gets mapped to E. That's fine. But then I mean, this is option B, and option C is that A is equal to E. But that'll also give a homomorphism. Let me refresh my memory on exactly what a homomorphism is here, right? Okay, so first we have the map 5x is equal to ax a squared, and we want 5xy is equal to 5x 5y. So I guess the idea here, the sort of, I don't really like this question. I guess it's all right. Some of the statements that are given, some of the answers that are given are too strong. Right, because it's asking for if and only if. Yeah, I believe the answer is actually going to be E. So anyway, let's just take this. Yeah, I'm not thinking straight. The question's fine. Now that I've written this down, I'm going to translate this to exactly what it means in the context of our question. So 5xy is a xy a squared. And on the right-hand side, I have ax a squared times a y a squared. So then I have a xy a squared is equal to a x a cubed y a squared. We're in a group, so I can multiply by inverses and so on. On left side, right side. So if I multiply by a inverse on the left, I get xy a squared is equal to x a cubed y a squared. I can just keep multiplying. I multiply by x inverse there, multiply by a squared, inverse on the right, multiply by the inverse of y, and I end up with E is equal to a cubed. And if I go backwards, if I start with this and go back up, I'll get what I want as well. So that one there, in fact, is the answer. Yeah, the thing that tripped me up here was some of the answers that are given. They imply that the map is a homomorphism, but the map being a homomorphism does not imply the option given, except for option E, which is that the identity is equal to a cubed. Yeah, not a bad problem. This is the kind of thing that might, I mean, it almost caught me out on something, but I think the thing that saved me here is realizing that both options B and C imply the map is a homomorphism, and so those you would need to think a little bit more about what you're actually doing. I almost got caught up on the logic here, but yeah, the answer is E, that a cubed has to be equal to the identity, and if this is, the map is a homomorphism if and only if this holds. If I have more to say about this one, I'll put it down in the description. Thanks for watching.